So, okay, inheritance. So this is what we are going to do, right? Inheritance is a fundamental object-oriented design technique used to create and organize reusable classes. The benefits of object-oriented programming is that you can reuse a lot of things. So once you write it, you can take it and use that class anywhere. As you see, I think I gave you examples when I showed you in chapter 4 or chapter 7. I can take a class and plug it into a new project, right? If you are doing, for example, if you're working on a grading system, you need a student. Well, you don't have to write it. You can just take that student class from another project and plug it into this project. So that's called software reuse. That means you, because, but inheritance is something else, right? But object-oriented programming has this feature, that is, you can reuse an object, a class. With inheritance, you can definitely reuse the parent class. So let's look at that. Okay. So creating subclasses. Now here, this is inheritance allows a software developer to derive a new class from an existing one. That means you can create a new one from an existing one, right? The existing class is called the parent class. Okay. And these are the terminologies. We call them parent class, superclass, base class. Those are the terminologies. The derived class is called child class, subclass, or derived class. Okay. The child inherits characteristics of the parent. That is, the child class inherits the methods and data defined by the parent class. Okay. So let's look at this example. This is a vehicle. Okay, if you think about it, a vehicle, it's a general concept, right? And then what is a vehicle? What else can be a vehicle? A car can be a vehicle. What else? A truck can be a vehicle, right? An SUV can be a vehicle. A bicycle even, electric bicycle maybe can be a vehicle. A bicycle itself is, but it's not electricity generated, powered. So, so in this sense, a vehicle is the superclass, right? And car is a child class. Okay. So inheritance relationships are shown in this, and this is inheritance, everybody. Okay. Remember, this is aggregation, right? This is the aggregation, and this is uses. You are using another class, right? So this is inheritance, aggregation, and uses. Those are the different symbols of relationships. Okay. Proper inheritance creates an is a relationship, meaning the child is a more specific version of the parent. If you think about it, a car is a more specific version of vehicle, right? A specific vehicle is a very general transportation tool, but a car is an actual more specific vehicle. And an SUV is a more specific vehicle. It's different from a car in some sense, but they all can drive, can brake, can reverse, can crash. They can pause. You know, all those functions, they all have gears, right? They all have a wheel. They all have windows, a body, a color. So there are some common characteristics, but for a car, it has a more unique characteristic than a general vehicle. An SUV has a more specific characteristic than from a vehicle. So that's why we have this superclass and child class. So let me ask you, which one is the parent class here?
Vehicle.
vehicle, right? And car is the child class. We also call it base class, right? Parent class, base class, and super class. And this is the derived class, the child class, and the, what is the other one? Subclass. Okay, those are the terminologies. So a programmer can tailor a derived class. What is a derived class, everybody?
The child class.
Child class, yes, the child class, okay? In this case, in the previous case, it's the subclass, the car class, as needed by adding new variables or methods, or by modifying the inherited ones, okay? So why do you have a derived class? Because this class has some more specific characteristics and behaviors. That's why you create this derived class. If it is exactly the same as the superclass, you do not need to create a new one, right? So one benefit of inheritance is software reuse. Okay, you are reusing the superclass. When you create the new one, remember, it inherits all the behaviors, all the characteristics from the superclass. So you are reusing that, okay? By using existing software components to create new ones, we capitalize on all the effort that went into the design implementation of the previous one. So you're not reinventing the wheel, you're reusing it, okay? So let's look at an example, okay? And in Java, we use the reserved word extends to establish an inheritance relationship. So car, that's the keyword, that's the class name, extends, okay, that's the keyword, signifying inheritance, vehicle. So which one? This is the current class, the derived class, and this is the parent class. You are extending it. You are adding more to this, this class. So this is saying car is extending the vehicle class. A car is adding more attributes and behaviors to the vehicle class. That's what this is. Okay, any questions, everybody? Okay, so let's look at this, this word class. I have it here. So let's look at, oh, I thought I had it. I closed it. Okay, so you can look at it, and while I'm starting this, look at that class, the two slides. Okay, I am going to delete this because this is the original one, okay? So this is, okay, let's look at Word. I'm going to close this one. Oh, let me pause for a minute. Okay, so if you look at it, let's look at the book class first. This is the book class, a very, very simple version of the book class, okay? It doesn't have any other methods because we are not really writing a book class. We are just using it to illustrate inheritance, right? So this is the class book. It has instance variable, pages, and it says protected. So here is protected. Remember, we learned what? We learned private, public, and now we have private, protected. Private means it's only visible to the methods in the class, inside the class, okay? Private. And public means it's visible to everybody, even a class that is outside of your package, your project, it's visible, okay? And so outside, I shouldn't say outside your project, outside your package. Okay, so that's public and private. And the main thing to remember is private is only visible inside the class. Protected, on the other hand, is visible inside the package. That means because this pages is protected, dictionary class can see it, and words class can see it. That's because it's protected. Okay, it's also visible to the child class. So if book has a child, that child can see this variable. That's protected. Once again, protected are visible. The visibility has two folds. One is it's visible to any child class. Two, it's visible to any class in the same package. Okay, so it doesn't have a constructor. As I said, this is just for illustration purposes. So two methods, right, using pages. This is the superclass. Okay, let's look at the dictionary class. Here is the dictionary class. Dictionary extends book. So who is the child class?
Dictionary.
Dictionary, right? And book is called the
Parent class.
parent class. Another word, another terminology?
Superclass.
Superclass and base class. Okay, and child class is also called derived class, subclass. The reason you need to know them is because people sometimes talk about these in different terminologies, and you need to know them, right, when you discuss projects. Okay, so now here, this is a private instance variable named definitions, right? A private instance variable versus the book class that is, why do I have so many open? I'm going to close them. Okay, and the book class, this is protected, remember. So this variable is only visible inside this class. Okay, so let's look at this method, public double compute ratio, and return, okay, cast the definition into a double because definition here is an int, and divided by pages. Where is pages?
In the parent class.
In the parent class, but you can directly reference it because it's protected. Okay, when we say you can reference it by name, this is what we meant by name. You don't have to call a method, say get pages. You don't have to do that. You can just use the name directly. That's what we meant when we say you can access it or you cannot access it. That means you can access it directly by using the name. Okay, so here, that's why, because it's protected. And now set definitions and get definitions. You understand those. So this is illustrating that it can directly access it because it is protected. Any questions? Okay, let's look at this driver. Okay, in the driver, we create a dictionary object, right? Webster is a dictionary reference. Okay, and it's a dictionary reference, and now it's created as a dictionary object. Okay, so let's see, Webster.getPages. Where is the getPages method? You have your own PowerPoints. You tell me, where is the getPages method?
The parent class.
In the parent class. Okay, yes, in the book class, the parent class. But Webster, what is the reference variable, Webster? What object is it?
It's a dictionary book.
It's
or
a
dictionary object.
Yes, it's a dictionary object, right? It's a dictionary object. But it's using a method in the book class. Why? Because it's a child of the book class. So it's spoiled. It can use anything in the parent. So here is the get pages, right? It can use that class because the book is dictionary's parent. That's why. Now this is what happens. Okay, Webster is a dictionary object. When you call get pages, the Java machine will first go to dictionary to see if you have the get pages method. It cannot find it. So it's just like you. When you cannot pay your balance due, who is responsible? They go after your parents. Okay, so you cannot find get pages in the dictionary class, so the system goes to the parent class and find the get pages method. If the parent doesn't have that method either, then it doesn't compile, right? So here, that's the procedure, goes to the child itself. If it's not there, goes to the parent. If this parent doesn't have it, go to the grandparent, okay? So that is inheritance at work, everybody, because dictionary doesn't have to redefine this method because it's defined in the parent class. So you are using it. That's what we, that's when we say, that's what we meant when we say reuse, right? Okay. And the get definition is, of course, in this word, in this dictionary class, right? Compute ratio, let's see. Is it in dictionary? Oh, yes, it is. So it's calling a method in itself. That is what this is. It shows you, first of all, it shows you how to extend a class, right? How to inherit a class. And then it shows you how inheritance is at work here. You're using a method in the parent. Any questions, everybody? No questions? Okay.
No.
Okay, let's look at this. So I explained all this just now, right? Okay. And if you don't understand, go back, rewatch the video or study this. I try to put the notes there to make it clear. So I didn't run it. Let's run it. The running is very simple, right? Number of pages and number of definitions. Okay. So if you look at this, this doesn't have any pages. So where does the page come from? Oh, it's initialized to 1500 from the beginning, right? So that's why pages is equal to, oh, this is set pages. So because it doesn't have that, let me see, definitions. Number of page, oh, number of pages, get pages. That's, it's not the constructor. It used the method, right? Not the constructor. I was looking at the constructor. It doesn't have a constructor. So it's empty, and then it will just use this method to get the number of pages. Okay. And number of definitions. It's using that method to get the number of definitions and compute ratio. Okay. So the protected modifier, I already explained that, everybody. Class diagram for words, okay? So this is uses, right? This is the uses relationship here, uses, and this is inheritance, right? So dictionary inherits book, and words uses dictionary. Okay, so once again, this is UML. I had one student who said it's machine something language, unified universal machine language. It's unified modeling language. It's a model. Think about this. This is a model, right? And you're using this, you're creating your classes based on this model. So this means it's protected. This means it's private. This means it's public. Those are the symbols. No ambiguity at all. Once you see this symbol, it's protected. This is public, right? This is private. So that's the UML. Remember, this is the class name. This is the variable instance data. These are the methods. Okay. So this is a little bit different from what we have, but you know. Okay, this is from the book, this diagram. Okay, any questions about this, everybody? No questions? No questions? Okay. The super reference, this is interesting. Okay, constructors are not inherited. You cannot inherit the parent's constructor. You can inherit any other methods, but not the constructor. Look at this. Okay, this dictionary inherits what? Inherits set pages, get pages. Okay, you can do you can do that. For example, I can say Webster dot set pages, right? I can say 450, and that's fine because you are inheriting. You inherit that set pages method. You also inherit the get pages method. That's why here you can use the get pages from the book, and here I'm using the set pages from the book. And now if I do this one, you will see the pages will be different. Right? Originally, it was 1500 and now it's 450. So we are inheriting the methods from the parent class, except the constructor. So you cannot inherit a constructor. Okay, even though they have public visibility, yet we often want to use the parent constructor to set up the parent part of the object. So as a child, you do inherit your parent. You inherit the attributes, you inherit the behavior. So when you construct a child, you want to construct the parent part first, and then add to that, right? That's the child part. So we use, because you cannot inherit the constructor, how do you construct the parent part? We use the super reference. The super reference can be used to refer to the parent class. So when you use this keyword super, you are talking about the parent class. And often it's used to invoke the parent constructor. Okay. A child's constructor is responsible for calling the parent's constructor. A child class should always call the parent's constructor first using the super reference. So this is important. A child class should always call the parent's constructor first, okay? Using the super reference, then constructor constructs its own part. So this means as the constructor of a child, you always call the parent's constructor to construct the parent part first, and then do your own thing. Always take care of the parent part first, and then initialize the variables of yourself. Okay. To be exact, the first line of child's constructor should use the super reference to call the parent's constructor. Okay, the super reference can also be used to reference other variables and methods defined in the parent class. So let's look at these words too. Okay, so I'm going to use this also. And you right now look at it. Okay, I will give you some time to look at that. And I'm going to open this one. So how about, I will pause it. The same thing, protected int pages, right? Okay, and this is the constructor. So in this class we have a constructor. When you construct a book, give me a number of pages, I will initialize it to whatever you give me, right? Okay, and the set number of pages and get number of pages. The same thing, except now we have a constructor, right? And so this is not initialized to 1500 anymore. It's initialized to whatever the user, the client program gives you, the client class gives you. Okay, that's the constructor. Now let's look at dictionary 2, that class. Okay, and once again, this is extends. That means it inherits from it inherits book 2, and this is the same. And here, let's look at this constructor. Okay, so dictionary, it has number of definitions. It also, a dictionary also has what? What else does it have?
Number of pages?
Yes, very good. Number of pages. It's not shown here because we don't need to mention it. It's already in the parent class. That's called, once again, software reuse. because you inherit that, right? So you don't have to restate that int number of pages because it's already in the book 2 class, everybody, right? Okay, it's already here. So dictionary really is made of number of pages and definitions. And so here, when you create a dictionary object, the constructor here, what do you need? You need the number of pages. You also need the number of definitions. This one is to satisfy the parent part. This one is to satisfy the child part. And to construct the parent part, remember, you cannot inherit the constructor. You can call it. So we use the keyword super. And super references the parent class. In this case, because it's used in this syntax, it's referencing the parent's constructor. So it's book 2. And what does it accept? An int, right? So here it's giving it an int. So after this statement, the parent part is constructed. That's what we meant when we say you need to construct the parent part first. Now you go back to that slide, you will understand it better, right? So we construct the parent part first always, and it's always the first statement to say in your constructor. And then we construct the child part yourself, okay? So definition is your own instance variable, and you initialize it here. Now your object is complete. You have a complete dictionary 2 object. Okay. So that's the super reference. Any questions, everybody? The other methods are the same. Okay. So
I have a question about the variable name.
Mhm.
So so it says super num pages. And if you go to the book 2 class, yeah, it says pages equals num pages. Does it have to? Yeah, is it going for the argument, or the not the argument? Sorry, is it? I forgot what it's called. The certain variable. That one right there. Yeah. Like it has to be the same like exact name as that.
No. Okay, let's change it. I will just change it to page. Okay, and here we just change it to, now, remember these are placeholders. They don't have to, they are just a name. So you can change it to pages. That answers your question, Jesus?
It does, but then how does it know what to change on the other in the parent class?
So when you do this super pages, right? This is calling the parent's constructor.
What if the parent has 2 integers for a constructor?
Then you need to give it 2 integers. You see, that's the thing. Because we're calling the parent constructor, whatever that constructor needs, you have to give it, you have to satisfy it. So if this needs 2 variables, then here you need 2 variables. So let's see, let's change it. That's a great question. How about I will say private string title. How about that, right? This is another one. And so because you have 2 instance variables, remember that, by the way, for your test, I make comments. So for each question, sometimes you think I answered it, what's wrong? Look at my comment. A lot of times, most of the times, I have a comment there telling you why. Okay, besides my explanation, when I grade, I also have comments. So look at that. So here, remember your constructor's function is to initialize all instance variables, right? So you need to initialize all of them. And for this one, I will just call it key. So you need to say title equals key. Okay, now we change this constructor, right? Let's go to your dictionary 2. And this will not compile. Why? It says add argument to match book 2. It needs an int, it needs a string.
So it goes by the signature?
Yes, yes, yes. It looks at the signature because this is simply saying you are calling the constructor. You're calling book 2. You are calling, even though it's named super, because how do you reference the parent constructor, right? That's how. You simply, instead of saying book 2, you say super.
Excellent. Got it. Thank you.
So here, now it doesn't compile because this does not match. You're right. This doesn't match the signature because book 2 requires two parameters. One is a string, one is an int. So you have to, I will just give it an int, okay? And now it's okay. So that's a great question, Jesus. I like that question because this way I get to explain it more and students may understand it better, right? Okay, thank you for asking that question. Any other questions, everybody? So when we do this super, what are we doing? I'm going to ask you. What are we doing when we do that? When we do that super pages title. Daniel, what are we doing there?
You're calling the constructor method in the
is it mine or yours? Why is it so low? Daniel, I think you need to increase your volume.
It calls the main method. It calls the constructor method in the main class.
It's still very, very small, the voice, but I heard you said you are calling the constructor of the superclass. That's correct. Very good. Okay. So this is calling the constructor of the superclass. Okay. That's it. The others are all the same. Any questions, everybody? Any other questions? No? Let's go to words 2. Okay. Dictionary Webster. New dictionary. This shouldn't compile, right? Did I? Oh, it compiles. The reason is I'm accepting only two variables, and title is just, I just put it here, hard code. This is called hard coding. You are putting the literal value there, okay, instead of accepting one. If I say I accept one, then it won't compile. Here it compiles, so the title will automatically be set to title. Okay, this is a dictionary, right? And once again, get pages. Where is get pages, Brian? Where is get pages? Brian, where is get pages?
Hang on.
I'm sorry, I didn't hear you.
Oh, so in book 2?
In book 2, that's correct. In book 2. Why can Webster, which is a dictionary object, call the method get pages? Why?
Because book 2 is the parent class and it's protected, so therefore the child class can access it.
Okay, if it's not protected, can you still call this method? Autumn, since you answered the question.
That one's tricky because I wasn't sure on that part. I'm gonna say yes, possibly.
You would say yes. What is the percentage of your confidence?
Like 50-50.
Aaron, if pages, num pages is not protected, can you still call this method? Aaron.
Yeah, I'm just thinking right now.
Okay. You say yes?
I would say yes.
Why?
Because what is it? Dictionaries, a child class of it?
Yes, yes. Dictionary 2 is a child class of book 2. So it's like you get to spend the money of your parents. You get to spend all the money your parents have. You don't even need their permission. As long as you state, I'm your child, then you can use the methods in the parents class. Okay, so Webster, even if we make that not protected, we make that private, you can still call that get pages method because it's right here, get pages. It's a public method and it's in the parent. And so Webster is a dictionary object, which is whose parent class is book 2. So you get to use that method no matter what, okay? Just to convince you, I will change that protected, okay? Let's change that protected to private. We put it as protected just to show that you can access it directly, right? Now we go here, it won't compile. It doesn't compile. Why? Because pages is private. Even though you are the child, you cannot access the instance variable that is private. Remember, we said if it's private, be you the grandparent, the child, the grandchildren, it doesn't matter. If I'm private, you cannot access me. Only the methods inside that class can access it. So what do we do here if we cannot access it?
Change it to get pages?
Yes, exactly. Okay. You can do get pages, right? Get pages or get num pages, I forgot. So you can do that. Okay. So it's just now we used protected because we want to show that in the child class, you can access it directly by name. But if it's private, you have to call the methods. And this is where object-oriented programming, the safety part comes into play. Think about it. If in book 2, you do not provide this method, get pages, okay, if you do not provide that method, in dictionary, there is no way you can access that number of page. If it doesn't provide you a tool, you cannot access it. So this, in a sense, protects the instance data. So as a class, if you say, these are my instance data, they are private. If I don't want you to change it in any form, I will not provide the tool, which is the mutator. Okay. If I don't want you to know what it is, I will not provide the accessor, which is the get method, right? So that's a way to look at this. That's why we say it's like a box. If it doesn't give you tools, you cannot really do anything to it. Okay. So here we get to use get pages because it's a method in the parent class. And this is the method in the dictionary 2 class. This is a method in the dictionary 2 class. And here I'm just, I want to do this just to show you. We haven't done that yet. Okay, so that is the super reference. Any questions, everybody?
So if dictionary 2 didn't have the super reference, then Webster couldn't have used pages.
Okay, let's
without
go back.
without
Ask your
using.
question again, Tyler.
So originally, when the Webster had pages and it was pulling from the parent class, if dictionary 2 class did not have the super num pages, it couldn't have called to the book 2 constructor.
Yes, that's
okay.
correct.
Okay.
That's the way. Okay, that's how you call the constructor of the superclass. Just know that. Okay, you say, how do I do this? There is a rule. The rule is you use the super keyword. That's the rule. And you pass whatever arguments it needs. In this case, it needs 2 arguments, right? It needs 2 arguments. So when you call it, you need to pass 2 arguments. Match the type, a number. And so this is calling the book 2 constructor. Okay. And so I'm going to restate this. When your child class constructs itself, that means in the child class constructor, the first thing to do is what? I'm asking you, what is the first statement? What's the first thing to do?
like you would put public and then match the name of your actual class, and then put your parameters.
Okay.
I feel like your question's very open.
Okay,
So
this
I'm
is
not,
my question.
really...
This is my question. What is the first statement in your child constructor? As a child class in your constructor, what is the first statement?
Well, in this one, it's to call to the parent.
Yes, always. Okay. A child class constructor, the first statement is to call the parent constructor. How do you call the parent constructor?
With the super.
With a super keyword. Right. So, okay, the first statement in the child class, in the constructor, the first statement is to call the parent constructor by using the super keyword, followed by the necessary parameters.
Yeah.
Yes.
Okay.
And after that, what do you do? Everybody, after the first statement, what do you do?
You initialize all the child's
yes.
instance variables.
Exactly. Okay. Initialize all the instance variables of the child class. So I'm going to say this again. What's the purpose of a constructor? The purpose of a constructor is to initialize all instance variables, whether it's given in the parameter or not. Even if it's not given in the parameter, you still have to initialize it. Okay. So that's why on your test, there is that question, right? P-person, to construct a person constructor, I give you one parameter, which is name. You need to write that constructor. A lot of you didn't remember to put age is equal to 0 there, because you need to initialize all instance variables, right? That's why. Okay, so the first thing is to call the parent constructor by using a super reference. After that, you initialize all the instance variables. That's how you write the child constructor. Okay, any other questions? No? Okay, let's continue. So we discussed this. Multiple inheritance. In Java, we do not use multiple inheritance. It's single inheritance. That means you can only inherit from one parent, and that parent can inherit from a parent. So it's one side. Let's say the mother side. You can only inherit from that side, not the other way. You don't have another parent. Okay. You can have great-grandparent, great-grandparent, great-great-grandparent, but not a separate parent. So C++ has multiple inheritance, and there are a lot of problems with multiple inheritance because you don't know where this method comes from, which class. You know, gradually it becomes very messy. So in Java, there is a single inheritance. But we can achieve multiple inheritance by using interfaces. That's something we will discuss later, okay? So that is creating subclasses. Let's talk about overriding methods, okay? A child class can override, I need to find override the definition of an inherited method in favor of its own. The new method must have the same name and signature. The new method must have the same name and signature as the parent's method, but have a different body. The type of the object executing the method determines which version of the method is invoked. The type of the object, okay? So what does that mean? So I'm going to ask you, what is the type of object? What is the type of object, Webster? What is the type? It is dictionary, right? It is dictionary. Who is calling me? Let me silence my phone. Sorry about that. So it's dictionary. That's the type of object. Okay. Whatever you say after new, that is the object. And we call this a reference variable. We call this the actual object. Okay. So let's look at this. Look at this project. Okay. Let's look at that. So I'm going to once again pause. So in this case, B is a book 2 reference variable, but it's actually instantiated as a dictionary 2 object. Does that answer your question just now, Tyler, I think, or Jesus?
Yeah, that answers it. Thank you.
Okay, so why can we do this? Because dictionary is a book 2. Dictionary 2 is a book 2. So this book is a reference variable referencing a book 2 object, right? A book 2, it's a reference variable. It's an address, basically. It's saying this address is pointing to a book 2 location. And dictionary is a book 2, so it's okay. So this is a book 2 reference variable, but it points to a dictionary 2 object. This Webster is a dictionary 2 reference variable. It's pointing also to a dictionary 2 object. So this is saying it's pointing to what type of object. This is saying the address, okay, the reference. So, okay, let's look at this. No, here. Okay, I'm going to close this. Okay, let's save. Now let's look at messages. Okay, so thought is, okay, let's look at thought. So this is a class and it has one method only. Once again, this is a simplified version of a class, right? No constructor, no nothing. It's just demonstrating the inheritance function here. So this is a message. In this message, you print out a thing, one statement. Okay, and then look at advice. Advice extends thought. It inherits thought. And it has a message, void message. It's exactly the same as this thought, void message. So this is called overriding. Okay, look at thought is the parent class. It has a method, public void message, right? Advice is a child class of thought. It also has a method called public void message. Exactly the same. If you look at it, exactly the same method header. But the implementation is different. Look at the implementation. So here it prints out warning, right? And prints out an empty line. And look at this. It also calls the superclasses message method. So when you want to call the superclasses methods, you use the super reference variable. You use the super keyword. So whenever you say super, you're talking about the immediate parent. So the parent, right? Message. This is calling this message. Okay. This is called message, no, not message, method overriding. If you look at this, we said the new method must have the same name and signature as the parent's method, but have a different body, right? That's what this means. It has the same name and signature, empty here, and void, the same, but the body is different. It's doing something different. Let's run. Okay, here, let's look at this. So part is a thought object, reference variable pointing to a thought object. Advice, dates is an advice reference variable. Please know that I'm I'm deliberately repeating these concepts so that it drills into your mind, okay, into your brain. So dates is a reference variable of advice. It's pointing to an advice object. Okay, parked message. So parked is a thought reference object. So it's calling the message in thought, which is this. It will print out this, right? And then dates is an advice object. So it will go to dates, go to advice, and do this, and then this, and then this, okay? And then I'm just doing this. So let's run. Okay, you look at it. So I feel like I'm diagonally parked in a parallel universe. That is the message from thought, right? Okay, that's the message from thought. And parked is a thought object, so that is correct. And dates is an advice object. And so when you call message, it goes to advice. So it will print out warning, and that's what it prints out. And after that, it prints out the empty line, which is this empty line here. And then it calls the message of the parent class. So it prints out this statement. That's these two correspond to each other. Super.message, and its output is I feel like I am. So this is evoking or invoke the parent's method message. That's this one. Okay, that's how you call a parent's method. You use the super keyword. Any questions, everybody? I will. How about I give you a minute to resume a recording, right? So if you look at these two, thought is the parent class. It has a method called message. And what does it do? It prints out this statement, trying to be philosophical. And advice is the child class. And it says, no, I think this way. I don't care about the parallel or things. I think this way. But as an afterthought, it says, okay, I will put your statement here, right? So it has its own body. That's what that is. Does this have to be here? Everybody, does this have to be here? Do you always have to call the superclasses method?
No, you can make it your own.
No, yes, no, you don't have to. You don't have to. You don't always have to follow your parent, but usually your parent is correct. So in this case, this is the parent's method and this is the child method, right? So you don't have to. Whatever you do, you just provide a different body. That's what that is. That's called method overriding. Any questions?
So it's like in the end, you're your own person, but you're also your parents' child. So
Yes.
it's like in the end, you're going to be, using their method, or like the method will be called to the end.
Mm-hmm.
I mean, just.
Yeah. And which method is being called depending on what object is being used. And that's what this means, okay? The type of object executing the method determines which version of the method is invoked. So here, parked, what type of object is it? It's a thought object. So the method used is in the thought class, okay? And dates is an advice object, that's the type, and the method used is in the advice class. So they are both calling message. And how does the system know which one to call? Because both classes have this method. So it depends on what object it is. That's what this means, okay? The type of objects determines which version of the method is used. So any questions? Everybody, any other questions?
So in the child class, like I know it has to have the same like signature and stuff, but can you use different variables like an int and a double in the child class?
Then it's not
Okay.
method overloading anymore. You are just providing a new message, a new method. That's a good question. Can we yeah, we can overload this method. That's called overloading, right? So if you thought is the parent class. So in advice, if you say, I'm going to provide another version, which is whatever the user wants to print out, then you can give it. And here you just, okay, this is a good question, Autumn, because now I can illustrate method overriding and method overloading, right? This is great. So what do you call this mechanism? Everybody, what is this mechanism called? Method
overloading.
Overloading. Very good, Jesus. Method overloading. Remember, method overloading means you have the same name, but you have a different signature, okay? Right? So here it accepts nothing. Here it accepts one string. So this is method overloading. Method overloading occurs in the same class. Method overriding occurs in two different classes. One is in the child, the method being overridden is in the parent class. That's the difference. So Autumn, does this answer your question?
Yes, it does. Thank you.
Okay. Any other questions? If you have questions, please ask. I like you having questions because that way it expands the concept and I can explain it. Otherwise, you know, right? Okay.
Could you run the overloaded?
Oh, can I run? I have to call it, right? So where is it? Is it in advice? Yes. So then we need to do, I'm just going to, this is something we will discuss in a minute. So now it's in advice. So dates message. Hello, I'm here. So this is calling this. This is not overriding anymore because in the parent class, you do not have such a method. Okay, so that's purely another method. And in this class, it's overloading, right? Okay, so here I'm doing this. And now when I run, it's here, right? That's just the method. Any other questions? So this is really overloading, overloading in the same class, right? In the same class. Okay. No questions, everybody? Okay, overriding, we discussed this. A method in the parent class can be invoked explicitly using the super reference. And that's what this is doing. Explicitly using the super reference. You can invoke a parent method by explicitly using the super reference. Okay. If a method is declared with a final modifier, it cannot be overridden. It's simple, it's final. You cannot override anything that's final, right? The concept of overriding can be applied to data and it's called shadowing variables, which is not encouraged. So why do we have to talk about it? This is from the publisher, this part. The meaning that you give the child class instance variable the same name, meaning that, okay, as that of the parent class, it's not encouraged. So that means you have a variable here in the parent class, okay? In book, you have pages. And then in dictionary, you have a variable called pages also. That's called shadowing, which is absolutely not encouraged. So we will not talk about that. Overloading versus overriding. I will let you read this. I discussed it just now. Can you override the parent's constructor?
No.
Now, where is Daniel? Why don't I see Daniel? No, Daniel is there. It's just somehow just now I thought, I didn't see Daniel. Okay, no, you cannot override the parent's constructor. So if you want to call the parent's constructor, you want to use it, what do you do?
Are we talking about just the parent constructor?
Yeah.
No, like nothing added by the child.
If you want to call the parent's constructor, what do you do?
Use this. Go ahead, Adam.
Oh, the super keyword?
Yes, you just
Sorry.
use the super keyword followed by the parameter. Yes. Okay, so overloading, overriding, I hope you understand it. Do you have any questions about this?
Is the parent's
True
constructor?
or false? I already have the go ahead.
Is the parent constructor can't be overridden because you're adding yeah, the parent constructor can't be overridden because you're adding another parameter sometimes by the child?
Yes, because you are your parent. Only you have some other features and behaviors. So you cannot override the parent. You cannot say, I'm not you at all. I'm going to do my own thing as you. No, you cannot, right? If you think about it, you can only add to it. You cannot completely say, you cannot obliterate your parent. No way. Look at your look, right? Look at your appearance. You can never. So that's why you cannot override the constructor. Using an everyday example, yes, you can only add to it. A child class may define a method with the same name as a method in the parent. That is true. I have the answers here. That is true. Why?
It's overriding, right?
Yes, that's called overriding. A child class can override the constructor of the parent class. Why is it false? I just said it, right? You cannot override. It's just a fact. You cannot override the constructor of your parent. You can add to it. You call your parent's constructor by using the super keyword and add your own thing to it. A child class cannot override a final method of the parent class. That's true. Why?
Because it's a final method. You can't change a final method.
Yes, because it's final. It is considered poor design when a child class overrides a method from the parent. It's false. Why?
Because that's part of the reason of having a parent and a child. A child is the same thing as a parent, but it adds its own thing to it.
Yes, that's very good. That's very good. Because, okay, both parent and child do that, right? But they do it differently. So it's good design, actually. So this is not true. Because you do something this way, the child will do it in a different way. Okay, a child class may define a variable with the same name as a variable in the parent. True, but shouldn't. That's the shadowing of a variable. We don't like that. Okay, so let's talk about class hierarchies. We might not have enough time, right? But still, we have about 15 minutes. Let's talk about this class hierarchies. Okay. Unless you have any questions from the previous lecture, everybody, any questions from what we just discussed? No? Okay. Class hierarchies, a child class of one parent can be the parent of another child. So here you look at it, right? This is easy to understand. This is the ultimate parent class, and reptile, bird, and mammal, they are all animal. But a snake is not a bird. A snake is a reptile. A reptile is not a bird. A reptile is an animal. Okay, that's the relationship, right? They go this way. They don't go horizontally. No relationship. Okay, except they are both. These are both animals. They are all animals. Okay, so that's that. These are called siblings, sisters and brothers. Other than that, they are not each other. A bird is not a reptile. A mammal is not a reptile. Okay, they are animals. So two children, you can read that. We just said that actually. Okay, the object class. The object class, object, okay, uppercase, everybody, remember this is uppercase. It's defined in the java.lang language package of the Java standard library. All classes are derived from the object class. All classes, any class is an object, okay. If a class is not explicitly defined to be the child of an existing class, it is assumed to be the child of the object class. So the string class's parent is object, random's parent is object. Let me ask you, who is the object? Who is the parent of book? Jawan, who is the parent class of book? Jawan? Jawan?
Yes, sorry, I went to the bathroom.
Okay, who is, so you might not be able to answer this question then. Who is the parent class of book? No? If you weren't here, you wouldn't know. Asa, who is the parent class of book?
Would it be object?
Yes, object, okay. So this is simply extends object, but it's omitted because by default, that's the case, okay? That's what that is. So any class is an object of, is a child class of object. Therefore, the object class is the ultimate root class, root of all class hierarchies. Okay. So the object class contains a few useful methods which are inherited by all classes. ToString. The ToString method, that's why I keep saying you should define your ToString method in all classes. Okay, the ToString method is defined in the object class. Every time we define the ToString method, so if the object class already have this method, why, when we define it in our own class, what is that mechanism called?
Overriding.
Overriding, right? Because your parent already have it, the same name, the same method, the signature, and you are rewriting it, you are redefining it. That's called overriding. The ToString method in the object class is defined to return a string that contains the name of the object class along with a hash code, which is not useful, right? So that is why we always override the ToString method by providing our own string. Okay, so I put this here so that I can remember. Override the ToString method in the book and dictionary classes. Okay, so let's look at this. If you look at this, in our book class, there is no ToString method, right? And in our dictionary class, there is no ToString method. So when you print it out, okay, that's why just now I have that print. I just want to show you. I deleted it, I think. Okay, let's print it out. So if I do Webster, right? If I print it out, this is a dictionary object. And remember, dictionary doesn't have the ToString method, but it will still compile. Why? Why does this still compile even though it doesn't have the ToString method?
It uses the default one from the object class.
Yes, because okay, when this statement is compiled, the compiler will look for the ToString method. Remember, when you use an object as an output statement, the ToString method is automatically called, right? So this is calling the ToString method. It will go to the dictionary class. Okay, okay, dictionary. oh, dictionary doesn't have the toString method, it will go to the book class. And then book class also doesn't have it. Once again, it goes to its own. It cannot find it. It goes to the parent. The parent doesn't have it. It goes to the parent's parent, which is object. And object has this defined. But object defined it to return a string that contains the name of the object class along with hash code, which is relatively the address. Okay, so now it will go to the object class to find the toString method and give you whatever that is. And you can see it is the class name followed by a hash code, which is not meaningful at all, right? If you do not define your toString method, it compiles because object has it, but it's not meaningful. What do? That's why you always override the toString method. So let's go and override it. Okay. Public, and you always have to do it this way because you are overriding it. That's why sometimes students say, I'm not going to call it toString. I'm just going to call it print. That's not okay. If you call it print, it's a completely different method. Okay, it's not the one in the object class. So when you print it out, it still is the class name and hash code. So you have to override it. You have to use the same name, the same parameter signature list. Okay, so what do? We return the pages, right? Return pages. And maybe add something. Number of pages, okay? And so you return that. That's the toString method. Now let's go to words, everybody. I added the toString method to book, remember. And this is a dictionary object, right? So this will call the method in the book class. Why? Because it goes to dictionary first, but dictionary doesn't have it. So it will go to book and use that version. And you can see the number of pages. The first one, this one, is from this statement, everybody. Okay, and the second one is from, where is it? My console. Okay, and the last statement, the last one, that is from this statement. So you can see it goes to book to call the toString, right? Because dictionary doesn't have it. Then dictionary not only has number of pages, it also has definitions. So we need to override the toString method of the parent. toString. And when you override the method in the parent, since the parent already have a toString here, since it already returns a number of pages, what you can do is you can utilize that, reuse that. How do we call a method from the parent class? Everybody, how do we call a method from the parent class?
The super keyword.
Yes, very good, Daniel. Super keyword. So let's just construct a string, right? Super, this means the parent, which is book, dot, and now you can call the toString. Okay, this will give you the number of pages, right? And then you will add your own. And your own is number of definitions. I will just write it. Plus definitions. I think I may have to add a new line character here. Okay, just so that definitions. and return. Always remember to return, right? So everybody, do you all understand this? Any questions about this? You all understand? Okay. So once again, this is calling the toString method of the super class, and this is utilizing the super keyword, right? And add yourself to it, and then return the results. Now let's see. When we run, you will see it's different, right? It has number of pages 450, number of definitions that. So now it's using the method in itself because it has it. If it doesn't have it, it will go to the parent to use the parent one. If the parent doesn't have it, it will go to object to use that default one because the ultimate parent is object. So any questions about this? That's the toString method. Any questions, everybody? Okay. And then the equals method of the object class returns true if two references are aliases, meaning the two references are pointing address, which is not useful. Okay, so the equals method is also in the object class, and it's also already defined. How is it defined? Okay, it returns true if two references are aliases. That means they are referencing the same address. Then it's true, which is not meaningful, right? When we test if two objects are true, for example, if you want to see if two students are the same, are equal, you want to look at the names, the telephone numbers, the addresses, the gender, the height, you know, all those attributes to make sure they are the same, or the social security number, maybe that one covers all. So you want to test if they are the same, you have to test that way. Basically, you are testing if all the instance variables match, not just addresses. If it's just aliases, then even if two objects, they occupy two addresses, but they are exactly the same. They have the same height, the same color of eyes, the same hair color, the same social security number. They should be exactly the same person. But this equal will return false because it tests the address, not the actual content. So that makes this equals method not useful. Okay, this is in the object class. And that's why we override it also, equals. So equals method, okay, dictionary, Webster 1 equals to Webster. If you do this, this is not meaningful, right? It doesn't mean much. This is aliases. The two are aliases. They are pointing to the same address. That's when we say it's aliases. This definitely will be the same. But you know, if you simply let's do this. Okay, let me finish this. Okay, equals to new dictionary, right? And then I will set the number of pages. They should be the same, right? They are pages. They both have exactly this much definition. They both have this much pages. So they should be the same. But guess what? They are not the same. I will also set this. Let's just make them exactly the same. So they are exactly the same. I'm going to delete this one. Okay, they are exactly the same, but let's see. But you will see they are not. I will just print it out. Webster dot equals. Remember, that's the method name. Dict. They should be the same because they have the same number of definitions and the same number of pages, right? But this should print out false. Why, everybody? Why? Because the equals method by default will test what?
The address.
The addresses. And they are two different objects. So the addresses are, of course, different, right? So when you test them, they are different. But in reality, if their instance variables are all the same, they have the same value for each instance variable, they should be the same, they should be equal. And that is the work, that is the job of each individual class. Because as the ultimate parent object, it cannot decide what is equality for each child. So each child will decide what is equality. That's why you should always override the equals method also, okay? And I explained that here, right? Yeah. So, okay, next time we will implement the equals method just to show you how to do that. Okay, so we will stop. You go. I want to tell you, everybody, just make sure you utilize what is given to you, right? If you look at the modules, I do have, let's go there. Okay, if you look at the modules, now we are doing chapter 9. You do have these videos besides this class, okay? I give you more examples here, and this will explain it further. I repeat those concepts and explain the concepts using programs, using code to explain it. So make sure you also watch these. Each one is not long, at most 25 minutes. When I made them, I kept that in mind. I didn't want to make it too long. So make sure you also utilize these sometimes students say, I'm looking for materials. What else can I do besides the book? Why do you go outside the book? And why do you go outside this class while all these references and materials are here? If you look at it, right, each one has these videos. So please utilize that. And so that we have 3 weeks to go for this semester. I would like to see everybody successful. I really do not like to see students fail, but it's in your hand, not mine. You are in control. So make sure you keep this in mind. All these are here. I'm going to post today's class here also. Okay, everybody. So